Hello everyone, and welcome to the second video on Unit 1.8, where we're going to talk about the difference quotient. So, what is the difference quotient? Well, given a function f, the difference quotient, which I'm going to now abbreviate dq so that we don't have to keep writing that out, is given by dq equals f of the quantity, so f parentheses x plus h, that's f of the quantity x plus h, minus f of x divided by h. Now, if this ever for this course, I'm not going to require you to memorize it. However, this will probably be required for you to memorize when it comes to Calculus Math 181. So it's in your best interest to try and memorize it for that if your plan is to go on. But for this course, if it is needed, it will be provided on exams. So that is the difference quotient. The reason why this is important is this has something to do with the derivative in calculus. In fact, this is the derivative in calculus, just without a limit sign. Um, so this is very, very important and will be useful later on. So it's not just some random thing that we're making you calculate and then just to punish you for taking a math course. No. Now, the key thing, though, and this is true here and in calculus, is you're not done simplifying. You're not done simplifying the dq until the h in the denominator has canceled. So do whatever algebra is necessary to cancel that h in the denominator. Whatever algebra can work, whether it be factoring to cancel or simplifying to cancel or finding common denominators, anything is viable to try and get rid of it. That's the end goal. So let's look at an example. Given that f of x is equal to 2x minus 3, find the difference quotient and simplify as much as possible. So dq, remember, you don't have to have it memorized, but it's always good to rewrite it just to free practice at memorization. F of x plus h over h, like that. And now, if you feel comfortable, you can definitely compute this as you're going along. However, I'm a person who likes to have this off on the side so that I don't muddy up my whole thing. So f of x plus h. That is f of the quantity x plus h, meaning that we're going to be taking every instance of x in our function. In this case, there's only one right here. And we're going to replace that x with an x plus h. That is to say, we're going to get 2 times the quantity x plus h minus 3. So that's going to be 2x plus 2h minus 3 when we distribute. Now, this is a little aside, very, very important because I see it happen all the time and I don't want it to happen to you. F of x plus h is not 2x minus 3 plus h. Please see the difference. Here, there's two h's, here's one. This right here on the right-hand side in red, this is f of the quantity x, then plus h on the outside. So, not inside of f. A lot of students will make this mistake. They'll just put like they see this of f of x plus h and they think they just want to add the h on the outside. That's not what this is. This is plugging in the value, quote unquote, of x plus h into the function. So you have to distribute it. If you do this, I guarantee you will get the problem wrong every single time. So now that we've got f of x plus h, we can plug it in and start simplifying or doing algebra, whatever is necessary. So f of x plus h is 2x plus 2h minus 3 minus, and I'm going to write this in red, so don't write this down, just pay attention. John Doe student is going to write 2x minus 3 like this, and then divide it all by h. And I'm going to tell you that John Doe student is wrong. And hopefully you see where he's wrong. He forgot the parentheses. And I know you're saying like, well, Phil, I know what I'm doing. I know I'll distribute the minus sign. And the thing is, I totally believe you. I totally believe you. But I don't trust wherever you're taking the exam or the quiz or whatever. It's always going to be a situation where you can't control everything. Maybe someone closes a door or your dog starts barking or something and you get distracted and then you forget to distribute it. So it's always in your best interest to distribute to make sure you put those parentheses. So parenthesis 2x minus 3. Now I can distribute that minus sign, and I get 2x plus 2h minus 3 minus 2x plus 3, all divided by h. And very nicely, the 2x's cancel, and then the 3's cancel, leaving us with just 2h over h, at which point the h's cancel, leading us to a final answer of 2. We know this is our final answer because the h in the denominator has finally been canceled in purple here. So that's how we do it. Now let's do it with a slightly harder example. Not harder, but just a little bigger of a function. So the difference quotient, dq, is f of the quantity x plus h minus f of the quantity x, all divided by h. So off on the side, I'm going to calculate f of x plus h, though if you want to do it as you're going along, be my guest. F of x plus h is going to equal 3 times the quantity x plus h squared minus 3 times the quantity x plus h plus 1. The x plus h is replacing every instance of x. So the x, like where my red dot is, that becomes an x plus h. This red dot becomes an x plus h. Oh, there's not a 3 there. Why is there a 3 there? I'm going blind. Okay. Now let's simplify it. So that would become 3 times the quantity x squared plus 2xh. Remember, you have to FOIL. It's not x squared plus h squared. You have to FOIL it out. That's why you get a 2xh. Then plus an h squared minus x minus h plus 1. And then distributing in the 3 finally gives us our answer of 3x squared plus 6xh plus 3h squared minus x minus h plus 1. Now we have everything we need for the difference quotient. We'll plug it in. That'll be 3x squared plus 6xh plus 3h squared minus x minus h plus 1 minus, and I'm going to put parentheses around it, and I meant to mention it earlier on. The reason why I have to put parentheses, if you're wondering why I have to, it's because I'm subtracting multiple terms. If I was just subtracting 3x squared, wouldn't have any issue because I don't need to distribute a minus sign. But since there's multiple terms, I have to distribute it. So that's going to be minus 3x squared minus x plus 1, all divided by h. And you've got to distribute this minus sign, and then I'm going to do some algebra on this same line. When I distribute the minus sign into the 3x squared, I get a minus 3x squared with a positive 3x squared. Those cancel. Then the minus x becomes a plus x. So negative x plus x, those also cancel. And then you've got plus 1 minus 1, so those also cancel, leading us to leading us to this, which is going to be 6xh plus 3h squared minus h, all divided by h. Let's make that nicer. Now, I know what you're thinking. You might want, like, maybe you're thinking that, oh, I can just cancel this h right here. Don't do this. That's not correct. Because in the numerator, this h is a term. It's a term of the numerator. There's 3 terms in the numerator. Whereas in the denominator, it's a factor. So you can't cancel terms and factors vertically. You can only cancel factors vertically. But remember, we're not done until that h in the denominator cancels. So maybe you noticed that there's a common factor of h amongst the 3 terms. This is h times 6x plus 3h minus 1 once we factor out the h. And aha, there we can cancel the h's and get our final answer then, now that we've canceled the h, of 6x plus 3h minus 1. That is our difference quotient. Last one for this video. Given that g of x is equal to 16 over x plus 9, find the difference quotient. So it's a different function. It's labeled g, but the definition of the difference quotient is still going to be the same. We're just going to change f to g. So dq is equal to g of the quantity x plus h minus g of x, all divided by h. And I'm going to calculate g of x plus h off on the side. So g of the quantity x plus h is equal to 16 over parenthesis x plus h plus 9, or 16 over x plus h plus 9. I do this first step for our notes. You can skip it when you're doing it yourself. It's just to show that I'm plugging it into the function. That's the main goal here. So now that we've got the simplified version of it, g of x plus h, so 16 over x plus h plus 9, then leave a little bit of space, then write the minus sign, and then write g of x, which is 16 over x plus 9, all divided by, in fact, I'm going to make this a big bar to symbolize that we're dealing with multiple fractions, all divided by h. So we can't cancel the terms in the numerator. We can't simplify it, at least not yet, and there's no way to cancel that h. So there must be something that we need to do, because we can't cancel them here because they've got different denominators, and there leads to our solution on how we're going to approach this problem. We need to find a common denominator. So we'll multiply the first term by x plus 9 over x plus 9, basically what it's missing from the common denominator. And then we'll multiply the second term by x plus h plus 9 divided by x plus h plus 9. And when we do that, we now get, remember to distribute. You get 16x plus 9 times 16 is 144, minus, in parentheses, 16x plus 16h plus 144, all divided by x plus h plus 9 times x plus 9, and then big denominator over h, which looks really, really intimidating until you remember that h is the same thing as h over 1. And remember that dividing by a fraction means you flip and multiply, so we could really treat this like we're multiplying by 1 over h, just to make it look less complicated. Too many fractions going on here. All right. And then the distribution of the minus sign happens. If you don't want to draw this that I'm drawing, like, you can skip it and skip any algebra that you feel like you can do in your head. Please do so. It'll make you a stronger mathematician. But this is just for completeness of our notes. So this becomes then 16x plus 144 minus 16x minus 16h minus 144, all divided by x plus h plus 9 times x plus 9 times h from the purple. And then, as we see, the 16x's cancel, the 144's cancel, and we're left with negative 16h, all divided by x plus h plus 9 times x plus 9 times h. Though if you wanted to skip this step and cancel it over here, I've had students do that. It just, I don't like doing that because it looks like we're canceling a term with a factor, which is not something you can do. I know it's because we cancel these things, and so the numerator is just a negative 16h, but I just don't like it the way it looks in the notes when we're looking back at our work. So this then is then going to be, now we can cancel the h's because they're factors, and you get the final answer, which is negative 16 divided by x plus h plus 9 times x plus 9, and that is our final answer. And that'll do it for this video, and I will see you on the next one.